Hi, we decided to do our project on concrete properties, and I'm Skylar Green.
I'm Akshay Patel.
I'm Caitlin Gainey.
And I'm Hunter Tapman.
So in our daily life, we see a lot of concrete in different types of uses. Some include concrete pavers, the concrete sidewalks that we walk on, concrete buildings in commercial construction, and in buildings that we see on campus, like Reynolds Coliseum, and even concrete canoes, like what our Fed Day project is.
So here I'm going to talk about the chemical makeup and the physical makeup of concrete. Concrete mainly has three components: cement, an aggregate, and water. You can see in the chemical equation shown below, the aggregate plus aggregate, water, and cement results in a like a very tight compacted compound, and heat is a byproduct of that. So we're going to talk about why heat is very important for the concrete mixture. This chemical reaction is a hydrolysis reaction. That's also important to note because water eventually will evaporate. So we'll talk about that.
There are three main types of aggregates that are used in concrete: crushed stone, gravel, and sand. The aggregates act as the base for the concrete. The bigger the aggregate, the more heavy duty and impact resistant the concrete is. So for sidewalks and buildings, you want larger stones like gravel, and then sand acts as a median to fill in the gaps for the aggregate.
Porosity deals with how much volume is being taken up by void space, especially in concrete. So when concrete is created, water and air create air pockets, and when the water evaporates, it leaves behind pores, and these contribute to around 12 to 18% of the concrete, but most of the time they're invisible. Porosity also deals with how dense or how strong the concrete is. So when the concrete is less porous, then the concrete itself is more dense and stronger.
For bigger projects like buildings or bridges, you want to reinforce concrete. You could use steel bars or steel mesh. These act as a base for the concrete to be molded around. And then for smaller, more artistic projects, you could use fiberglass to hold the concrete in the shape that you want.
Common density of concrete is 150 pounds per cubic feet, but it also ranges depending on what type of density you want. Low density concrete usually is around 90 to 120 pounds per cubic feet, whereas high density concrete is upwards of 180, 190 pounds per cubic feet. Density is pretty much proportional to strength. So the higher density it is, the more strong it's going to be because there's less air, there's less possibility of cracks. Density is also kind of proportional to water resistance. So the more dense it is, there's less space for water to seep into the pores. What we see on campus is a pretty dense concrete, where pretty dense but not completely dense concrete, because water is able to seep in, so it doesn't run off and create a slick surface. Density is also seen, the difference of densities when concrete is curing. So it starts off as a water, like a liquid type material where it's very less dense, then transition to a very hard, very dense material.
The curing process is vital to concrete formation. Specifically, the proper moisture content and maintaining that is necessary, because without the proper moisture content, the strength of the concrete could be limited. The timing of the curing process is also very important. It takes roughly 28 days per cubic inch of concrete for it to be at its max strength, so cured completely. But within 24 to 48 hours, your concrete is dry enough to walk on or touch, but it's not completely cured to be to its max strength. To speed up this process, you can add heat, but as mentioned before, you have to maintain the proper moisture content. So by adding too much heat, you can throw off this moisture content and result in cracks in your concrete and less strong material.
And here's some of our citations.